Hey everybody, Mr. Judson here. So this is my way of doing videos when I haven't got my television set to work at. What we want to do today is we want to take a look at what's called the second fundamental theorem of calculus. Okay, we already know what the first fundamental theorem is. That's when you do an integral from a to b, you integrate, plug in the b values first, subtract what you get when you plug in the a values. Well, this is our second fundamental theorem. And it says this, it says if f of x equals the integral from c to u. So c means we've got a constant right here. It's got to be a number. In order for this to work, this has to be a number. And u is just some expression. X squared, this integral could go from 2 to sine of x, any expression up here, of f of x dx, then the derivative of this function is just f of u, which means you take this u and plug it in wherever you see an x, times the derivative of that boundary. So it almost looks kind of like a chain rule, and it sort of acts like that as well. All right? So important to realize that when we say little f of x, that's the derivative of big F. Okay? So this little f is the derivative of that. You know, you would think that if you take the derivative of something and then turn around and integrate it, you should come right back to the same thing. But see, we're plugging this expression in, and we got to take that into account as well. Okay, let's look at an example and see how this works. All right, so it's, you know, here's our first problem. We're trying to find f prime of x, the derivative of big F of x, the derivative of this. So normally what you'd think is you'd go through and just do the integral, plug this in first, then plug in a 2, subtract what you get when you plug the 2 in, and then once you get your answer, turn around and take the derivative. Okay? The second fundamental theorem is supposed to make that a quicker process. So what this rule is saying is, whatever that expression is right there, plug it into your function. Alright, so let me do that. F prime of x is going to equal, I'm going to put 4x in place of that t. So 4x squared plus 4 times the derivative of this expression. Well, the derivative of 4x is just 4. And all I got to do now is simplify it. So if I square this, I would get 16x squared plus 4. Got to multiply that by 4, so I need to distribute it to both of these. So that would be 64x squared plus 16. There's my answer. Okay, so we're trying to find the derivative of this function. Instead of doing the integral and plugging everything in and working it out and then turn around taking the derivative, we're saying just plug this into the function and multiply by the derivative of that. Now, one thing they're going to ask us to do on some of the problems is they're going to ask us to actually do the integral and then take the derivative and show that it works. So if I had to do that, I would say, okay, the integral is going to be t cubed over 3 plus 4t. And I'm evaluating that from 2 to 4x. So go ahead and plug that in. If I do 4x cubed, I would have 4 times 4 times 4, which is 64 x cubed over 3. Put in a 4x here, so 4 times 4x, that would be 16x. Minus what you get when you plug in a 2. So plug in a 2, you get 8/3. Plug in a 2 here, you get plus 8. And now simplify this and take the derivative. Well, this is all just a number right here, right? So if I'm going to take the derivative of this, I'm just going to say bring that 3 down in front. I'm going to multiply by 3 and then divide by 3, so it's still 64x squared. And then the derivative of this is just 16. That's what we got. Derivative of this is just a number, or just 0, right? This is just a number. And so the derivative of that would just be 0. Okay. So some problems today, they'll ask us to actually do the integral, evaluate it, and then take the derivative of this. So when you do that, boom, there's your derivative. It should match up with this over here. All right, you guys go ahead and try this one. They're telling us that f of x is equal to the integral from pi over 4, it's just a number, just a constant, to x squared, some expression, of sine of theta d theta. And they want us to find the derivative of this whole thing. So again, this variable will always be different from this variable right here. We've got to have some place to plug that x squared in once we do this integral. All right, so you guys go ahead and try this using the second fundamental theorem of calculus. And remember, this is meant to be an easy problem, okay, not a hard problem. All right, so all I have to do is plug that expression in right here, sine of x squared, and then multiply by the derivative of that. That's it. I'm done. Right? So these problems are supposed to be easy. So 2x sine of x squared. So now, just because they're going to ask us to do this, actually do that integral, and once you get the answer, then take the derivative of it and see if that's what you get. Alright, so if I was to do that integral, the integral of a sine of theta is a negative cosine theta, being evaluated from pi over 4 to x squared. And so let's see, if I plug that in there, I'm going to get a negative cosine of x squared minus what you get when you plug this in. So that would be I'm subtracting a negative cosine of pi over 4. Now, again, if you look at this and you go, well, that's just a number, and the derivative of it's going to be 0, then yeah, you can think of it that way. This right here is what f of x is equal to. Oops, let me do this. All right, so if I wanted to take the derivative of this now, I've got this negative sign, and the derivative of a cosine of x squared would be a negative sine of x squared times the derivative of the angle, which would be 2x. And let's see, this right here is just root 2 over 2, which is a number, so the derivative of that is 0. And so what I got, this is f prime of x. So f prime of x, negative times a negative, that's a positive. I'll write this 2x out in front, and then sine of x squared. Same thing. It's not like this is a huge amount of work here, but if we know the rule, this is obviously a lot faster. All right, let's try one more problem. All right, you guys go ahead and try this one. And this time you don't have to verify that it's true. Just figure out what the derivative of that function is. Alright, so all I got to do is plug 2x into this function. So I get the square root of 2x plus 1 over 2x times the derivative of what we just plugged in, which is 2. And so if I distribute that, I'm going to get 2 root 2x plus 2 over 2x, which would equal 2 root 2x plus 1 over x. There's my answer. And we actually don't know enough to verify this one. If you tried to integrate this right here, think about that. That's t to the negative 1. So add 1 to the exponent, and divide by the new exponent. Oops. Can't divide by 0. There's a problem there. So we don't know how to deal with that yet, but we will. That's coming. So that's why I didn't want you guys to verify this one. All right, you guys, second fundamental theorem of calculus. It's a pretty easy idea, but it's an important one too. Always shows up on the AP test for those who are taking it, always. And so this is something we want to make sure we know and understand. All right, let me get you guys an assignment. All right, so before I give you this assignment, I'll just kind of warn you, not real pleased with the problems that our book has. Most of them are f of x equals the integral from 5 to x of some function dt. And so you plug in an x and then you take the derivative of it and you just get 1. So after you do a few problems, you kind of look at it and you go, oh, all I do is just plug an x in and I'm done. We got to always think that you have to multiply times the derivative of this. A few of the problems have something more than an x in it, but a lot of them just have x, so they're kind of wimpy problems. I think we'll see some better ones later, but for some reason they did that. They probably could have done a better job. All right, so here's what we got. This is the end of week 3. It's our Thursday piece. We're doing page 293, 294. We're going to do 69 to 86, and we'll do all of these. And this should go pretty quick. I mean, this is not very hard. It's once you get in the rhythm of it, it goes almost as fast as you can write. All right, you guys, that's it. That's all we have for today. You guys have a good weekend. I will see you. I will definitely see you on Monday. I don't know if I'll be down here in Oregon or if I'll be back, up at Wilson by then, but I will definitely see you guys on Monday. All right? All right, you guys take care. Be safe. Talk to you later. Bye.